Hello students of students of class 10. Chapter is triangles. Now exercise 6.2. I am going to start from question number 3 because 1 and 2 you can do yourself. I am going to start from question number 3. In the question number 3, the figure it is given to you, and here it is given LM is uh, this is the figure. LM is parallel to CB and LN is parallel to CD. We have to prove that AM by AB is equal to AN by AD. Now, how to proceed? So here, this is the figure. This is the figure. A, M, L, B, C, and D. Here it is given that in the figure it is given that LM is parallel to CB and LN is parallel to CD. To prove that, we have to prove that AM by AB is equal to AN by AD. We have to prove this. So proof. In triangle ABC, your LM is parallel to BC. This is given to you. So from theorem, this is the theorem from theorem 6.1. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. From this theorem, uh, this is AM by AB is equal to AL, or you at first you can say that AM by MB is equal to AL by LC. This is from theorem 6.1. Now you can write this also like this: AM by AB is equal to AL by AC. You can write this like this also. So this is equation 1. Now in triangle ADC, again your LN is parallel to CD. This is given. Therefore, we can say that AN by AD is equal to AL by AC. This is equation 2, and from theorem 6.1 we can state that from 1 and 2 we get AL by AM by AB is equal to AN by AD. This is proved. This is question number this is question number 3. Question number 3. Now I am going to question number 4. Question number 4. Question number 4. Again question number 4. Here you see the figure it is given to you. This is the figure, and here DE is parallel to AC and DF is parallel to AE. So you have to prove that BF by FE is equal to uh, BE by EC. Now again I have to draw the figure. The figure is like this. This is your figure. A B, see, this is your figure, D, F and A, E, joined it. Now here it is given, in this figure it is given that DE is parallel to AC and DF is parallel to AE. We have to prove that BF by FE is equal to BE by EC. Now your proof. First of all, I am going to select this DE parallel to AC. DE parallel to AC. Therefore, in triangle ABC, your DE is parallel to AC. It is given. Therefore, BD by DA is equal to BE by EC. This is equation 1, and we get this from theorem 6.1. Now again, in triangle ABE, DF is parallel to AE. Your DF is parallel to AE. DF is parallel to AE. So again we get that BD by DA will be equal to BF by FE. This is equation 2 from theorem 6.1. We get this from theorem from 6.1. From 1 and 2 we get BE by EC is equal to BF by FE. So here I have proved the statement. So this is question number 4. Now I am going to question number 5. Question number 5. This is the figure given to you, and here DE is parallel to OQ, DF is parallel to OR. We have to show that EF is parallel to QR. So question number 5. Here you see the figure. It is this is the figure. This is the figure. Here again D, and this is F, this is E, and P, Q, R, O. Here it is given again, in this figure it is given that DE is parallel to OQ and DF is parallel to OR. We have to prove that. We have to prove that EF is parallel to QR. So proof. In a triangle POQ, your DE is parallel to OQ. Therefore, PE by EQ is equal to PD by DO. This I get from theorem 6.1. Again, in in triangle POR, your DF is parallel to OR. So therefore PF by FR, this is equal to PD by DO. This is equation 2 from theorem 6.1, and from 1 and 2, we get PE by EQ is equal to PF by FR. So from theorem, this is the theorem from theorem 6.2. If a line divides any two sides of a triangle in the same ratio, that the line is parallel to the third side. From this theorem, we can say that therefore EF is parallel to QR. EF is parallel to QR from theorem uh, from theorem 6.2. So this is proved. Now again, question number 6. Question number 6, you see. Question number 6. In figure 6.21, A, B, C are this is the figure, are the points on uh, OP and OP, QR and QR and OQ. OP, OQ and OR. We have to prove that such that it is given that AB is parallel to PQ and AC is parallel to PR. We have to prove that BC is parallel to QR. So the figure is here like this. This is your figure. This PQR, and here O. This is your A and B. This is your C and this is BC. So here in this figure it is given that AB is parallel to PQ and AC is parallel to PR. We have to prove that that BC is parallel to QR. So how to do this proof? In triangle OPQ, here it is given that AB is parallel to PQ. Therefore, from theorem 6.1, we can say that OA by AP is equal to OB by OQ. This is equation 1 from theorem 6.1. Now again in triangle OPR, here AC is parallel to PR. This is given to you. So we get OA by AP is equal to OC by CR. This is equation 2 from theorem 6.1. So from 1 and 2 we get this is OB by OQ is equal to OC by CR, and from theorem 6.2 we can state that BC is parallel to QR. This is from theorem 6.2 we can state this. This is proved. So my next question is, this was question number 6. Now my next question is question number 7. Question number 7. Question number 7, it is using theorem 6 point prove that the line drawn to the midpoint of one side of a triangle parallel to another side bisects the third side. So this is my triangle ABC. This is my triangle, and a line drawn to the midpoint. So this is the midpoint parallel to the third to another sides of a triangle bisects the third side. This is equal to this. So here it is given, what it is given in triangle ABC, D is the midpoint of of AB. D is the midpoint of AB, and DE is parallel to BC. To prove that AE is equal to EC. So proof. Now, since DE is parallel to BC, this is given to you. So from theorem 6.1, AD by DB is equal to AE by EC from theorem 6.1. This is equation number 1. And from here, again, since D is the midpoint of AB, so AD is equal to DB. Now, from equation 1, AD by DB is equal to AE by EC. Now instead of AD I am going to write DB. So DB by DB is equal to AE by EC. So this cancels out. So 1 is equal to AE by EC. So EC is equal to AE. So this is proved. Now I am going to question number 8. Using theorem 6.2, prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. Here, this is your triangle. ABC. The question states that line joining the midpoint of any two sides of a triangle DE, this is the D and E are the midpoints of AB and AC. It is given that in triangle ABC, D and E are the midpoints of AB and AC. D and E are the midpoints of AB and AC. To prove that DE is parallel to BC, we have to prove that DE is parallel to BC. Now proof. Your AD by DB is equal to DB by DB equal to 1, since D is the midpoint of AB, therefore your AD is equal to DB. Again, this is equation 1. Again, AE by EC, that is equal to EC by EC, this is equal to 1. This is equation 2. Here again, since E is the midpoint of AC, therefore your AE is equal to EC. So from equation 1 and 2 we get AD by DB is equal to AE by EC, and therefore your DE is parallel to BC from theorem 6.2. This is proved. This is your question number 8. Question number 8. Now I am going to question number 9. Question number 9. Question number 9. Here question number 9. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at O, so that AO by BO is equal to CO by DO. So here you see a trapezium is given to you. This is your trapezium. This is given to you. Your trapezium is ABCD and the diagonals intersects at O. The diagonals intersects at O. So diagonals intersect and AB is parallel to DC. It is given to you. It is given that what is given that ABCD is a trapezium. This is given to ABCD is a trapezium and the diagonals intersect at diagonals intersect at O. So intersect at O. To prove that, we have to prove that AO by BO is equal to CO by DO. A construction, we have to do a construction, that is a line is drawn through O. A line is drawn through O. A line is drawn through O parallel to DC. A line is drawn through O parallel to DC, which intersect AD at E, which intersects AD at E. Intersects at AD at E. Now proof. In triangle ADC, your EO is parallel to DC. This I got from construction. Therefore AE by ED is equal to AO by OC. This is equation 1 from theorem 6.1. So again, since your EO is parallel to DC and AB is parallel to DC, this is given. Therefore, we can conclude that EO is parallel to AB. Now, from in triangle DAB, now in triangle DAB, EO is parallel to AB. Therefore, DE by EA is equal to DO by OB from theorem 6.1. This we can write as EA by DE. EA by DE is equal to OB by OD. This we can write it as EA by DE is equal to OB by DO. This is equation 2. So from 1 and 2 we can conclude that AO by OC is equal to OB by OD. Now just we can also write like this. by OB is equal to OC by OD. So this is proved. Now the last question is, here this is your last question, question number 10. Here the diagonals of a quadrilateral intersect each other at O such that AO by BO is equal to CO by DO, so that ABCD is a trapezium. Here a quadrilateral is given to you. Here A, B, C, D is a quadrilateral given to you, and diagonals they intersect at O. The diagonals intersect at O. So we have to prove that, given it is given that ABCD is a quadrilateral. ABCD is a quadrilateral, and uh, the diagonals intersect at O. We have to prove that AO by BO is equal to CO by DO. No, such that this is also given to you, this is also given to you, this is also given to you. You have to prove that to, and AO by BO is equal to CO by DO, this is given to you. You have to prove that ABCD is a trapezium. You have to prove that ABCD is a trapezium. So here you have to do a construction, that is, through O you have to draw a line parallel to DC which intersects AD at E. Through O a line is drawn parallel to DC which intersect AD at E. Now proof. In triangle ADC, your EO is parallel to DC. This I got from construction. Therefore, AE by ED is equal to AE by ED is equal to AO by OC. This is AE by ED is equal to AO by OC from theorem 6.1. This is equation 1. Again, here you see it is given to you, again AO by BO is equal to CO by DO. This is given to you. So we can write this like this also. AO by CO is equal to BO by DO. This is equation 2. So from equation 1, that is AE by ED is equal to AO by OC. Now AE by ED can also be written as, instead of AO by OC, I can write this as BO by DO. So I can write BO by DO, AE by now here you see AE by ED is equal to BO by BO by DO. So in triangle ABD, what I got in triangle ABD, what I got, that is AE by ED is equal to BO by DO, or we can write it like this also, ED by AE is equal to DO by BO. We can write this like this also. So DE by AE is equal to DO by BO. So therefore EO is parallel to AB from theorem from theorem 6.2 from theorem 6.2. Now now see, now EO, and again EO is parallel to DC, which I got from construction. Therefore I can conclude that AB is parallel to DC. Therefore ABCD is a trapezium. Therefore ABCD is a trapezium. ABCD is a trapezium. Proved.